Hi everyone, welcome to this episode of Kuipert Labs. In our video today we're going to be looking at the concept of how we write ionic formulas, or how, when we're looking at ionic compounds. Okay, so in our previous video where we talked about ionic bonding, okay, so we introduced this idea that some compounds are ionic. Okay, so they form from positive and negative ions. And then we've got ionic bonds, also known as electrostatic forces of attraction. Okay, so this is what holds everything together, and we introduced this idea of this lattice work arrangement. If I can just quickly rebuild it to illustrate a little bit here. That we end up with this lattice, this kind of alternating pattern of positive and negative ions kind of connecting with each other in 3D. Okay, so remember, so it looks flat here on the page, but it's extending out in all directions. Okay, so what we're going to think about now is, all right, well, how can we use a formula to express how that compound is put together? Because remember that when we're thinking about our chemical formulas, just like you've done in the past, that we're thinking about it in terms of, so uses element symbols. We have subscripts. So if we're thinking about, say, water, the 2 in water, so which tell us the number of atoms. Or in this case, we're going to see ions of the given element in the formula. Okay, and then the other thing with the subscripts is that they come after the element they refer to. So if we look at water over here, so we're seeing that the 2 refers to the hydrogen and not the oxygen. So we have 2 hydrogens for every 1 oxygen, not 2 oxygens for every 1 hydrogen. Okay, so that's kind of a key thing to appreciate. Okay, so what we're going to do is we're going to go through a couple of quick examples. I'm going to try and use my use a particular kind of technique to help visualize things for you, and that is kind of thinking about things as a seesaw. Okay, so thinking about this side being positive and this side being negative charges, and we're looking at balancing. Because when we think about an ionic compound, what it is, we say, just like with an with an atom in and of itself, we say that an ionic compound is neutral overall. So an atom contains charged particles, but we have a balance of positives and negatives. 4 protons requires 4 electrons, and when we change that, we turn it into an ion. But what we're looking at here is that when we form a compound from ions, all our positive and negative charges balance out. Okay, so let's see if I can use some different colored pens. Okay, so we're going to have a look at when we form a compound from sodium, a sodium ion and a chloride ion. Okay, so sodium ion is 1 positive charge. Okay, so I'm going to represent that over here with a circle with a plus in it. Okay, to representing that an ion, and it's got 1 plus inside it. Okay, our chloride ion has a 1 minus charge, and so I'm going to represent that with a circle with a minus in it. Okay, now what we would see here is that what I need to do is I need to make sure that the number of positive and negative charges balance on this seesaw. So I have 1 plus over here, and I've got 2 minuses over here. So for every 1 sodium, I need 1 chlorine. So what I do then is to write my formula. I write sodium, and then I write chlorine. And that's my formula for sodium chloride. Now, what that essentially is saying, I've got 1 sodium and 1 chlorine, but the idea is that in chemistry, as in life in general, that we try not to make extra work for ourselves if we can avoid it. So what we do is that we say, rather than writing 1s all the time, that we just write no number and assume that that means that it's 1. And that if it was something different, we'd write it to be different. Okay. Now, one technique that you can use to help you in writing these formulas is that we can say, all right, I can write the formulas for my ions here, and I can just imagine that I've got 1s written here. Okay, so that's 1 plus and 1 minus. What it does is I can bring that 1 down over here, and I can bring this 1 down over here. We call this the crossover technique. Okay, and so then I would say, all right, Na1Cl1, and then I can take the 1s away to simplify. Okay, so I can use that to help me balance it out. All right, let's have a look at another example. Okay, so let's clean up those things. Okay, so let's say that I had a compound formed from potassium, which forms an ion of 1+, and oxygen, which forms a compound of 2-. Okay, so that is over on this side. So I'm going to still stick with this same kind of idea, that I've got a potassium ion that has 1 positive inside it. And now I'm going to use over here. I'm going to do my oxygen, but I'm going to do it this one, and I'm going to write it with 2 minuses. Okay, so I've got a single thing that contains 2 negative charges. Now the reality is, what we were saying is that it needs to be neutral overall. And so at the moment I have 1 plus and 2 minuses, and that's not balanced. It's not neutral overall. So what I need to do is I need to say, right, well, rather than just deciding to kind of change potassium and all of a sudden just muck around with that, which I can't, I can, however, change how many potassium ions that I have to balance it out. So what I can do here, so I have 2 pluses on this side, I can add a second one into my compound. So that is, I have 2 potassiums for every 1 oxygen. So what I would write then is I've got the symbol for potassium, and I've got the symbol for oxygen, and I want to show that I have 2 of these. So I'm going to put a subscript of 2 after my potassium. Now, I could also write my subscript of 1 over here, but again, we said that unless if it's 1, I don't need to write that. Okay, and so this is the formula for that compound, which is called potassium oxide. Okay, so this is potassium oxide, and then I'll show you how we can use our crossover technique to get to the same result. So if I had K plus and O2 minus, okay, that my 1 plus can come down over here, my 2 from my 2 minus can come down over here, and so I end up with K2O1, and then I just get rid of my 1 to make K2O. Okay, now what I suggest for you to do, what I really want you to do is, as you're starting off, is think about it like this. Okay, so in terms of balancing positive and negative charges, because I don't want you to rush into this sort of an approach, because it can be a bit plug and chug, that you just kind of learn how to do it without any concept of why we do it. And so seeing this in terms of, right, well, we have to have positive and negative charges balance out. Okay, let's look at a third example. Okay, so this will be our final example, but this one's going to kind of stretch things a little bit further. Okay, so let's say I've got an aluminium 3+ ion, and I've got an ion from sulfur, which is in group 6, so it forms a 2- ion. So what I have here, so this is probably the most complicated one you'd encounter, okay, so I'm going to show that, alright, so over on here I've got a single ion that's got 3 pluses inside it. Okay, it's a 3+ ion, 3 positive charges. And over on here I have a single thing that's got 2 minuses inside it. Okay, so far I've got 3 and I've got 2. Now, we know neutral overall, we need the same number of positive and negative charges on each side. But I can't just kind of decide to delete one of these, or kind of remove a positive or a negative, or add in an extra one just because it feels nice. Okay, all I have to do is I can change how many of each of these things that I have. Okay, so let's say, alright, let's say I've got a lower number over here. Let's say I add a second one. Okay? Alright, so what I've done now is I've changed this, and so I have 4. But the reality is that I've added 1, but now I have 1 extra negative charge, and so I have 3 pluses. Okay, so let's say then, alright, I'm going to add a second one of these to kind of keep going. Okay, but what I've now done is I've now ended up with 6 pluses and 4 minuses over here. But now, all of a sudden, I do have the option now to add an additional one over here, and so that takes me up to 6 negative charges. Okay, so I've got 6 pluses, 6 minuses, okay, and so now I'm balanced. I've hit my goal. However, now I need to start to write the formula, okay, to express that for every 2 aluminiums, I have 3 sulfurs, 3 sulfide ions. So for every 2 aluminiums, I have 3 sulfides. So this is called aluminium sulfide. If you were in the US, you'd call it aluminum sulfide, but we won't go there. Okay, so aluminium sulfide, and it has the formula of Al2S3. Okay, so we could use our same crossover technique if we were, once you're that bit more confident. Okay, so the 3 comes down here, the 2 comes down here. Okay, so then you end up with the same result of Al2S3. Okay, all right, get going with some of those practice questions. If you've got any questions, just let me know. Thanks for watching. Bye for now.